Welcome, ladies and gentlemen. So what I'd like to do is show you how to simplify radical expressions with a higher index. And what we've previously talked about is simplifying radicals using the square root as well as using the cube root. And the main important thing is understanding that identity element, that the square root of x times x, or the square root of x squared is just equal to x. The cube root of x times x times x is equal to the cube root of x cubed, which is just x. So the purpose, it doesn't really matter how, what the value is of our index. That just tells us we want a value raised to that exact same power, or we want our radicand to be multiplied by itself that many times. Therefore, then we can simplify it. So, when looking into these, I wrote some very common square numbers. I wrote some very common cube numbers. But you can see here we have fourth root, fifth root, and sixth root. So what I'm going to do is just kind of write in some of the common fourth root and fifth root, sixth root. You can see for the square roots, I went all the way up to 15 squared, whereas the cube roots, I only went up to 7 cubed. Actually, I'll write them down. For the fourth root, it's even going to be shorter. So let's do the fourth root. So that means a number that's going to be multiplied, fourth power. So that means it's going to be a number multiplied by itself 4 times. So 2 times 2 times 2 times 2 is going to be 16. 3 times 3 times 3 is going to be 81. 4 times 4 times 4 is going to be 216. 256. So you can see these are quickly getting much larger. 5 raised to the fourth is 625. And you can see any of the fourth root, we're not getting any bigger than that. So therefore, let's go to the fifth root, or fifth power. So for the fifth power, let's do 4 times 4 raised to the fifth power would be 2 multiplied by itself. 2 multiplied by itself, 2 multiplied by itself 5 times, which would be 32. 3 multiplied by itself 5 times is 243. And let's do 4 raised to the fifth power, which is 1,024. And then let's do the sixth power, because we do have 1/6 root. OK, so that'd be 2 multiplied by itself 6 times, which is 64. And let's do 3 multiplied by itself 6 times, which is 729. OK. So I just like to use these numbers because, again, you could always use prime factorization. And there's nothing wrong with prime factorization. But again, when you start doing prime factorization with large numbers of 625, it takes a while. Just even watch fourth root of 16. If I do the fourth root of 16, we could either use prime factorization, meaning rewrite the number as a product of its primes. So all you simply need to do is just factor it out. OK, so therefore, the fourth root of 16 is equivalent to the fourth root of 2 times 2 times 2 times 2, which is a product of its prime numbers. Now, if the square root of x times x is x, if the cube root of x times x times x is x, that means the fourth root needs to be of x times x times x times x is just going to equal x. So I need to have my number multiplied by itself 4 times, which in this case we do. The fourth root of 2 times 2 times 2 times 2. So whatever the index is, that's how many you need to group of the same value to eliminate that root, or the radicand, which in this case would just be 2. I can do the same thing for 81. Just break it up. So that's going to be 9 times 9, 3 times 3, 3 times 3. So therefore, that's the fourth root of 3 times 3 times 3 times 3, which is the same thing as 3 to the fourth power. So if the square root of x squared is x, the cube root of x cubed is x, that means the fourth root of 3 to the fourth is just going to equal 3. So you can either group them or rewrite them as an exponent and use the inverse operation that way. And that's basically the way that I prefer to kind of look at this. And that's why I kind of wrote these down here, is because if the square numbers usually people remember the easiest. Cube numbers you start to. But the fourth root and fifth root and sixth root, I wrote those down there because the majority of us do not have those memorized, or even we have to use a calculator or have to work it out to remember them. But let's just think about this. So if here's the fourth root here, you can see the fourth root is, or 256 is 4 to the 4th power. So I can rewrite this. Rather than doing prime factorization, which takes all that time, I can rewrite that as 4 to the 4th power, because 4 squared is 16, 4 cubed is 64, 4 to the 4th power is 256. Now, by using my identity element, I'm just left with 4. If you look at 625, that's going to be 5 to the 5th power. So, I'm sorry, that's 5 to the 4th power, which is just equal to 5. Now let's get into the 5th root. Well, you can see the 5th root, the 5th power here, is 32. 2 raised to the 5th power is 32. So 5th power of 2 to the 5th power, which is the same thing as 2 times 2 times 2, which you would get if you did prime factorization. But to me, this is much easier just to get 2. Now, where we start getting a little bit confusing is once we start doing ones that are not evenly go. So these were all 4th quartic numbers, and here's a quinctic number. That means numbers that can be raised to the 4th power, so it's easy to simplify them. However, this bottom run are ones that are not quartic, quinctic, or raised to the 6th power type of numbers. So for instance, the 6th power, which is right here. Oh, actually, I did do this one. 6th power equals like 64. That's 2 to the 6th power. Actually, I did cheat. I stepped ahead of myself, which is 2. You could obviously do prime factorization, but it's much easier. Much easier this way. The 5th power, I guess I did do this one as well. 5th power, you can see that's 3 to the 5th power, which is just 3. 4, 48, 4th root, which is here. So we don't have a, so you can see for the 4th power, we don't have a 48 here. So we want to determine what is the largest number raised to the 4th power that evenly divides into 48. Well, our only option here is 16. And 16 does go into 48 3 times. Okay, you could obviously do a prime factorization, and you'd see you get the exact same results. And 16 raised as a 4th power is 2 to the 4th power. And I'm going to separate that. Actually, let's separate these. So I can rewrite times 3. Now I can separate these from my power product rule. M times n is equal to the square root of m times the square root of n. So I can now separate these, which is going to be, let's see, the 4th root of 2 to the 4th power times the 4th root of 3. Well, 4th root of 2 to the 4th power is 2 times the 4th root of 3. I cannot simplify, so I'm going to leave it just like that. Okay? If you're having trouble with that, you can always go back to prime factorization. So for instance, the 5th root of 64. Prime factorize this. 8 times 8, 4 times 2, 4 times 2, 2 times 2, 2 times 2. So the 5th root of 64 is equal to 2 times 2 times 2 times 2 times 2 times 2. 2 raised to the 6th power. However, we can only group them as far as how large our index is. So we can only group 5 of them, right? Group 2 of them. Index is 3. Group 3 of them. Index is 4. Group 4 of them. Index is 5. So the 5th root of 2 multiplied by itself 5 times is just 2. And then that's multiplied by the 5th root of 2. All right, last but not least, we want to look at the 6th power. So we looked at the 6th power. We see that 128 is not a number raised to the 6th power. So we want to look at what is the largest number raised to the 6th power that divides into 128. We can see we have 64. So we have the 6th power of 64. 64 divides into 128 2 times. Okay, now the 6th root of 64, again, 64 is a number raised to the 6th power, so which is going to be 2. 6th root of 2 to the 6th power is just 2. We can't take the 6th root of 2, so we'll just leave that on the outside. So there you go, ladies and gentlemen. That is how you simplify radicals raised with a higher index.